So we're on day 3, and we have this. We had this in differentiation too, where we kind of look at the context of the problem, and so how can we relate that back to the calculus? And so when we did that first semester, it was all about relating what the context was back to rates, recognizing when they were asking for a rate, and how the different ways that could happen. And so now we're doing kind of the same thing, and recognizing how that relates to integration, or specifically the fundamental theorem of calculus. So we have this model of the fundamental theorem of calculus. Trust in that model. Okay, math is like that, super predictable, where we have a rate that we're integrating, and that can be represented as a difference in two function values of the antiderivative, right? That represents a change, which is what a difference is. And so fundamental theorem of calculus part 1 is used to accumulate a value. That's what this whole symbolism is, right? That's we way back at the beginning of the semester, we were calling this the accumulation function, right? So we're accumulating value. Another way to say that is to find a change in the value if we know the antiderivative, right? And that's our fundamental theorem. And so we're going to build on that. If we know the initial condition is represented here by the A value, right? This is where we start. This is where we end, lower bound, upper bound. So this is our initial condition. So if we know the initial condition, then we can use that fundamental theorem to find the final value. And so all we're doing algebraically is taking that f of a and bringing it to the other side, right? Adding it to the other side. So this is it's kind of our new tool, I guess you could say it, where we want to find this final value. So basically it's kind of like we're looking at this expression, and it's kind of like we start here at f of a, and this represents how much we change over that time interval from A to B, right? So start value plus change is final value, right? That's kind of what we're looking at in really general terms. This is just the math equivalent for that, the calculus symbolic notation for starting point, change, final point. Okay? So questions about that? So that's our contextual applications. We're going to fit what we're seeing in our question stem into this sort of format. Now, if this makes you really uncomfortable and you want to stick to FTC, we just know we're solving for this thing. That just means you're putting the number on the other side. You're going to bring it over eventually anyway, and that's fine. So any questions? Okay, so how does the context of the question relate back to the fundamental theorem? The question has you either finding a change in a value or having you find how much will be present in the future. Okay, so contextually speaking, we're either being asked to find this, in which case it doesn't matter about our initial condition. I think we ran into that a couple of questions like that yesterday, where it was asking you to find the change in a value. And it gave you an initial condition, and you're like, what do I do with this information? And the answer is nothing. You know, if you just ask to find a change in a value, it's just asking you to, like, sometimes it'll give you an initial condition just to throw you off. Okay, but if it asks you to find how much will be present in the future, or where are we at the end, then we need that initial condition. I mean, we need to know where we start in order to answer that type of question. So that's kind of the contextual sort of game we're playing. Is, are we being asked for a future value, or are we just being asked to find the change? Okay, so we've got day 4 notes. That's for after break. We've got some topic questions in AP Classroom, and then we've got some con in con. So those are the tasks for today. I'll be around to check in the notes in just a second, and also answer any questions you might have.